Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer a question from an old paper from June 2015. This is the International A-Level Edexcel S1, question number 8. And I've actually answered this question some years back, but I didn't fully complete the whole question, and some people have been asking me to answer the question, and the recording and the old question, there's certain aspects of it that I think I can improve on. So I'm going to just do the whole question again. Okay, so now we have here a histogram. And in this histogram, we have not been given a scale for frequency density. We have been told that there are 200 people represented in this histogram. So the histogram in figure 1 summarizes the times in minutes that 200 people, 200 people spent shopping in the supermarket. So this whole thing has 200 people representing or being represented in it. It says, give a reason to justify the use of a histogram to represent these data. So the most important aspect of the data such that it requires a histogram is that it's continuous data. So we can say that the data, involves time, which is continuous data, which is continuous. So they're looking for the fact that it's continuous. Okay, this word continuous must be in there to get the 1 mark. Okay, it's continuous data, so therefore we need a histogram, right? So that's good enough for that 1 mark. Just if they see the word continuous there, you'll get the mark. Okay, rather than discrete. Given that 40 people spent between 11 and 21 minutes shopping in the supermarket, estimate the number of people that spent between 18 and 25 minutes shopping in the supermarket. Okay, so now we've got to use the fact that there are 200 people in this survey. And if we look at the rest of the questions, like for example, it tells you to calculate the median time and they tell you to find the fx and so on. What would be a good idea for us to do would be, for the purposes of this question and for other parts of the question, would maybe to work out the frequencies involved in all of these bars. Okay, some of them I'll do later, but we'll make a start on it now, such that when we get to the other questions, we'll be able to answer them also. So this will help us answering this first question. Now, there's a few different strategies you can take in finding, what we're looking for, right? We know that there's 200 people altogether. We know that there's 40 people in this section over here. This is representing 40 people, okay? So what we could do is we could make a frequency table from this, and we can work out what the frequency densities are for each of these bars, and then we can continue, right? I think that would be the better strategy here, because counting the number of squares and some of these sections that we need are not going to be exact, especially when it says between 18 and 25. It's going to be a bit cumbersome to count all the little squares. All right, and so what I suggest we do is the following. Let's work out what the frequency densities are for each of these. And what I'm going to do is I'm going to make a little table and we'll fill it in as we go along. So we have 1, 2, 3, 4, 5, 6, 7 categories. 1, 2, 3, 4, 5, 6, 7 categories. So I'll do that. I'll make a table involving 7 across. So I'll make it 8 across actually, because we need the title. All right, so have I got it there? Where did it go? Here it is. Okay, so I'm going to make this frequency table. I'm going to draw it up here when we've got space. Okay, so this is going to be our frequency table. So this is our time. This is our frequency. So let's look at the first, between 11 and 21. Between 11 to 21, we have a frequency of 40, they told us. There's 40 people represented in there. I should have made another column as well. Can I do that now? Let me see if I can adjust it. Am I able to adjust it? See. Add table shade. Properties. No, I don't think I can. It doesn't matter. Can I? Let's have a look. If I do this. Oh, that doesn't help me. insert row. Okay, good, I can. So I'm going to make another row here for frequency density. Frequency density. Okay, so we got 11 to 21, and we're going to be dealing with up to 25. So I'll do 21 to 26 for now, and then I'll deal with the others later. 21 to 26. Okay, so we know that the frequency density for the first bar from 11 to 21, that's basically 40 divided by 10. Okay, 40 divided by 10, that's 4. So the frequency density there is 4. The frequency density is the frequency divided by the interval. Okay, so 40 divided by 10 is going to give me 4, right? So I know that this is the frequency density. So now I know the frequency densities. I can work out what all of these are. So if that's 4, that's like 1, 2, 3, 4, 5, 6, 7, and 8. Those are all the frequency densities. We can make the frequency density scale now. So now I can work out for the second bar. This is from 21 to 26, which is a bar width of 5. And the frequency density for this second bar is up to 6. All right. So the frequency in this bar is going to be 6 times 5, which is 30. So I know that there's 40 in this group and there's 30 in that group. Okay, all together. Right. And I can do the same for the rest of them. I can say from 26 to 31. Again, that's 5. And we can work out the frequency density, which is 7.2. Okay. And we can multiply 5 by 7.2, which is going to be 36. And we can carry on. All right. I'll leave that to later because I think that's coming later. But what we can do here is we can at least answer this part of the question. So we want to find the number of people that spent between 18 and 25 minutes shopping in the supermarket. So let's go to 18. Okay, 18 is going to be, that's 11. That's going to be 12, 13, 14, 15, 12, 13, 14, 15, 16, 17, 18. Okay, 19, 20, 21. So 18 is here. That's going to be 18 because that's 11. Okay, plus 5, that's 11. That's going to be 16, 17, 18. Right, so we need to know between 18 and, let me just change the, okay, make it slightly different. Okay, between 18 and, okay, good. Between 18 and 25, it says 25. Yep. So now I'm going to make a line up to 25. 25 is going to be 1 away from 26. Each of these is 1. So I can make 25 from here, from there onwards, up. I'll change it in a minute. I thought it was sorted out, but it wasn't. So just make that accurate. So for this, I'll change it to red and just make it dotted. Okay. So what we're looking for now is how many people are in this region over here. Okay, how many people are in this region over here? We got this region and this region, and we can take each of these separately. So I can see here, for example, for this, let's start with this one. Here you've got 3, okay, out of 10. You can see this is like 3/10 of the whole thing because this takes up, altogether there's 10, 10 rows or 10 columns here. Okay, and this is 3 columns out of the 10. So we can say that the first part is going to be 3/10 of 40. So 3/10, let me change the color. So we have 3/10 times 40 plus, and then here we have, you can see this is 5 columns altogether, and we've got 4 of them shaded. So that's 4/5 of 30 plus 4/5 of 30. Okay, so that's going to give you 3 times 4, which is 12, plus 4 times 6, which is 24. 12 plus 24, that gives you 36. So we've used some sort of proportion to work out what we need. Okay, we could have done it by counting all the little squares. We could have said that here we have 3 times 4, 12 squares. Okay, and here we have 5 times, that's 10, 20, 30. Okay, that's 150 squares. We could have added them together. We could have counted the squares all together for the whole group, okay? Or we could have said that here we have 40, okay? We have 800, no, this is going to be what? This is going to be 8 times 100, is that 100? 8 times 25 represents 40, so we could have worked out some proportion. Okay, but this is, I think, better because it's going to help us with other parts of the question later on. If we have this table ready, it will help us for other parts of the question. We can fill in the rest of the table and then use it for other parts, which we will need to do. Okay, so that's part B done of this question. 36 people spent between 18 and 25 minutes shopping in the supermarket. Okay, so there's the answer to that question using proportion here with histograms. Now, part C of the question says, find the median time spent shopping in the supermarket by these 200 people. So if we go back to our table here, we have a total of 200 people. Okay, so I'll just write it here. We have the total people is 200, as it told us in the question. Now, the median, which is Q2, is found by taking the total dividing by 2, which is 100. That's going to be the place we're looking for, the 100th position. We don't say, oh, 100th position, that's a whole number. So we take that and the next value because it's an even number, there's 2 median terms. We don't say that for continuous data. We just take the number of terms, divide by 2, whatever comes up, whole number, decimal, whatever it is, we take that value. So it's the 100th term we're looking for. So we need to find the group first, which contains the median. So we're going to look for the group which contains the median. So we go back. Now we need the 100th term. Okay, that's 40 plus 30, which is 100. 100 plus 36, sorry, 70. 70 plus 36 is 106. So we can see that the 100th term is going to be in the group 26 to 31. So it's in the 26 to 31 group. That's the group which contains the median. So let's make our little diagram. The beginning of this group is 26 in terms of its value for time, and the end of it is 31. There's no gap, so we can leave it as 26 and 31. By the start of the group, we have got to the 70th term. Okay, so by the start of the group, we got to the 70th term. By the end of the group, we've got to the 106th term. Because if you do the cumulative frequency, 40, 70, 106. So by the end of the group, we got to the 106th term. Okay, so there's 36 entries in the group. Okay, so I'll do that with another color to make, I'll do that more accurately or more neatly, I should say. So we can see that the total group width of this group in terms of the entries is 36. Now we're looking for Q2, which is the median, which is the 200th, is a 100th entry, not 200, 100th entry. Okay, the 100th entry, that's what we're looking for. So we need the 100th entry. Okay, so now what we can see is the 100th, the entry that we have, which is the 100th entry, is 30 into the group. Okay, so we can say Q2 is equal to 30 over 36. Well, first 26 plus 30 over 36 times the width of the group in terms of the values of time, which is 31 minus 26, which is 5. That's going to give you the value for Q2. All right, so we have 26 plus, we have 30 over 36 times 5. And that will give you the value of the median, which is 30.16 recurring. 30.166 goes on. So you're rounding this to 3 significant figures, you're going to get 30.2 minutes. So that is the value of Q2. So Q2 is 30.2 minutes, the median. Okay, so there's the answer to question 8, part C. And now we're going to go on to part D. And now for part D, we're told that the midpoint of each bar is represented by X and the corresponding frequency by F. Show that the sum of Fx equals 6,390. So I'm going to go back to the original diagram. I'm going to complete this because that will help us with answering this question. So we'll fill in the rest of this table. Now we have 26 to 31 already done. The next category is 31 to 36. So 31 to 36. And then we have 36 to 41. 36 to 41. And then we have 41 to 51. 41 to 51. And the final group is 51 to 71. 51 to 71. So there's no gaps in these groups, which is good. And we can now work out the frequency of each of these. So I'm going to fill in the frequency densities first, and then we'll work out the frequency. So the third bar we worked that. That was this one here. Where is it? So 1, 2, 3. So yeah, we worked out this one. That was 7.2, and multiplied that by the interval that gave us 36. For the next bar, 31 to 36, okay, which is this bar over here. Okay, so these have been done. This one, this one, this one. Here we got the frequency density is 8. Okay, and the width of the bar is 5. So 5 eighths of 40. That's 40. And for the next one, so this is done now. So the next one we have the frequency density is going to be 2.8. 2.8. And again, the width of the bar is 5. So 2.8 times 5, that's going to be 14. Okay, 10 plus 4, 14. Right, and then 41 to 51, the frequency density, so this one is now done. The frequency density for this one is 2. So 2 times, that's going to be 10, that's 20. So there's 20 in this. And the final bar from 51 to 71, okay, that frequency density is 1. Okay, so you have 1 times, again, 20, so that's going to be 20. So let's just make sure that they add up to 200, just to make sure. So 70 plus 36, that's 106. That's 146, 160, 200. So the sum is 200. Okay, the sum of the frequencies is equal to 200. So that matches with our original understanding. So now it tells us in the question, in fact, what I'll do is I'll take this table now. I'll move it to that part so that we can deal with it over there. And I'll add what I need to add. So I'm going to take this here and put it in this section. Make it a bit smaller. Okay, so we're going to use this table now to deal with the rest of the question. Okay. Now, it says show that the sum of fx equals 6,390. So we're going to deal, we've got the frequencies here. Okay, so I'll just highlight the frequency. That's f. This is going to be f. Okay, and x is going to be the midpoint of these groups. So I'll write the x. In fact, what I'll do is I'll write it up here. Write the x up here. Okay, those are the frequencies. I'll write the x's up here. Halfway between these groups. So to find the midpoint, we add them together and divide by 2. There's no, so it's 11 plus 21 divided by 2. That's going to give you 11 plus 21. I'll just do them on the calculator to make life easier. So 11 plus 21, 21 divided by 2. Okay, that's going to give you 16. So 32 divided by 2, that's halfway 16. And this is going to be 21 plus 26 divided by 2. So you have 21 plus 26 divided by 2. So I'll just change that there. And that gives us 23.5. So that's 23.5. Then we got 26 plus 31 divided by 2. Okay. Plus 31 divided by 2. That gives us 28.5. And we got 31 plus 36 divided by 2. So 31 plus 36 divided by 2. So I'll change this here. That gives us 33.5, 33.5. Then we got 36 plus 41 divided by 2. So 36 plus 41 divided by 2. That gives us 38.5. Always be checking to make it sure it makes sense. It's halfway between these. And then we got 41 plus 51 divided by 2. 41 plus 51 divided by 2. That gives us 46. And we got 51 plus 71 divided by 2. So go to here. And that gives us 61. Okay, so these are our values for x. Okay, so these are our values for x. So our f is this, our x is that, and we want to find the sum of fx. Okay, so let's just find what we could just do that in one go. We can show that the sum of fx is going to be 16 times 40 plus 23.5 times 30 plus 28.5 times 36 plus 33.5 times 40 plus 38.5 times 14 plus 46 times 20 plus 61 times 20. And that will give us the sum of fx. Let me just make a bit more space here. Okay, so this is going to give us what? Let's calculate it. It's a bit of a number crunching kind of question here. But anyway, so you have 16 times 40 plus 23.5 times 30 plus 28.5 times 36. You have to be very careful not to make a little mistake here, mess up your whole question, plus 33.5 times 40 plus 38.5 times 14, okay, plus 46 times 20 plus 61 times 20. Okay, 6,390, 6,390, and that's what we had to show. So just be careful not to make a silly mistake when you are, putting these in your calculator. I guess they wanted to give us the answer so that you could be sure that you've done the right thing. So there's the answer we've shown. Making this frequency table kind of helped us to make it a bit less complicated from the beginning. So that's good that we did that. Now then for part E, it says, given that the sum of fx squared equals 238,430 for the data shown in the histogram, calculate estimates of the mean and the standard deviation. Okay, so the mean, okay, which is, you can say, is x bar, or we can call it mu if you want, is equal to the sum of all of the entries divided by the number of entries. Okay, so this, we can't actually find the sum of all the entries. Why? And the reason why, we can see, one of the things that gives us a clue to that is calculate estimates of. Why are there only estimates? Because we have group data. So I know that there are certain times, there were 4 times between these values. We don't know what the actual times were. We just know they were between these values, so that we take the mid-interval value for us to be able to work out the mean. All right, so this is here a estimate of the sum of all of the times in the data, an estimate of that. We can't find the actual times because we don't know the actual data. So this estimates that time, okay? So what we have here is an estimate of the total sum of the times. So the mean, or an estimate of the mean, will be that 6,390 divided by the 200, which was the number of entries. So if we take the answer and divide it by 200, that gives us 31.95. It's an exact answer. We'll leave it like this. 31.95 minutes is an estimate of the mean. So we can say x bar is equal to 31.95. So we found an estimate of the median to be 30.1 and an estimate of the mean to be 31.95. Okay, and then we got to find the standard deviation. So this is part one. Now the standard deviation, okay, is the square root of the variance. And the variance is equal to the mean of the squares minus the square of the mean. So the standard deviation here of our x values is going to be the square root of the mean of the squares, which is basically the sum of fx squared divided by the number of entries, the sum of the frequencies. That's the mean of the squares minus the square of the mean, which is what we found just now, the sum of fx over the sum of f, which is the mean, and that has to be squared. Okay, the mean of the squares minus the square of the mean. So that was going to be equal to the square root of the mean of the squares, which is 238,430 divided by 20. That's the mean of the squares minus the square of the mean, which is the square of this value. I can use this exact value here because it wasn't something I rounded. Otherwise, I would use this fraction. Because it wasn't rounded, I didn't round it. It's like this exact value. I can use it like that. That's fine. And that will give us our answer for the standard deviation of x. Sorry, yeah, standard deviation sigma x. I'm not very good at writing standard deviation symbol anyway. So that's going to equal what? Let's use a calculator to find out. We're going to have here the square root of 238,430, okay, over 200 minus, brackets, we're going to have 31.95. So I don't need the fraction there. 31.95 squared. And that should give us the standard deviation, which is 13.0899. 13.0899 goes on. So we can say, therefore, the standard deviation for x is going to be 13.123 SF. So we found the standard deviation and we found the mean. Now we're going to move on. And the next part of the question, part F. Now for part F, it says a coefficient of skewness is given by 3 times the mean minus the median over the standard deviation. Calculate this coefficient of skewness for these data. So I've collected the mean, the median, and the standard deviation values that we found, and I've put them in like their more precise, forms before rounding, and we're going to use that to find the measure of skewness. So we have 3 times the mean, which is 31.95, minus the median, which is 30.166, divided by the standard deviation, which is 13.0899. Okay, and that should give us a measure of the skewness. So if we take that, we have 3 times, in brackets, 31.95 minus 30.166 divided by 13.0899. That gives us 0.4088. 0.4088 continue 09. Okay, so that's the measure of skewness there. We have question part G, question 8 part G, which is really, I think, the question that was intended by the student to inquire about in this question. This part was the thing which I think where the student had some issues. So the manager of the supermarket decides to model these data with a normal distribution. Comment on the manager's decision. Give a justification for your answer. So we worked out that the skewness measure the measure of skewness was equal to 0.409. 0.409, which shows slight positive skew. Okay, slight positive skew. All right, we can also see from the fact that Q2 is less than the mean. We can also see that Q2 is less than the mean. This also shows slight, basically positive skew. They're almost, you could say this, or you could say that they are almost the same. Okay, but Q2 is slightly less than the mean. As we see, Q2 is 30.1 and the mean is 31 or 32.0, you could say, 31.95. Okay, so they're kind of like very close to each other, right? Just 2 minutes apart. Okay, so we know that this gives us positive skew. Why? Because we know that when you have your bars, the tallest bar is always the mode, and then there's the median, and then there's the mean. So if the median is less than the mean, then you have this positive skew. But if the median was greater than the mean, now remember the mode, the median, and the mean. The height of the median bar is always bigger than the height of the mean bar. So if it's got negative skew, it'll look like this. So here we have positive skew because the median is less than the mean. Okay, this is the mean, and this is the median. Or this is the mean, sorry, and this is the median. Okay, the one that's the lowest one is always the mean. Okay, so we can see that we have negative skew. So there's two actual answers that could be given here, and your answers, as long as you justify them, you will get the answer correct. Although the best answer really is that there's very little skew. Very little skew. Okay. Therefore, his decision is good. It's a good decision. All right, because a skewness of 0.409, generally, if the skewness value is between minus 0.5 and 0.5, that's considered very little skew. Okay, if it's more than those values, then you would say, okay, it's a bit more skewed. You could say it's skewed, but here you could ignore this skew, right? That's something that you can bear in mind. And the fact that just by looking at the time in minutes, it's two minutes difference. It's not really that much if you consider the time that we got. We're talking about half an hour, so it's like 2 minutes is not really that much. So we can say that there's very little skew, so his decision is good. But if you were to say that we have positive skew, okay, therefore, okay, skewed data, and then you justify, therefore, unwise decision, that would gain you the marks as well. Okay, that would also gain you the marks. Okay, but the best, I think, would be for you to write this. Okay, very little skew, therefore his decision is good. So you could mention the skewness being this value, or you could mention, the mean and the mean and the median being almost the same value. Okay, you could mention that, both of those things, and you would be perfectly fine in getting the 2 marks. Okay, so that's how you would deal with this question. So in general, if you have a measure of skewness, which is between minus 0.5 and 0.5, that means it's quite, it's quite close to normal distribution. If it's more than that, then you're moving out of the normal distribution kind of range. That's kind of like a rule of thumb here. Okay, so I hope that was clear. Other questions from this paper can be found in the playlist for this paper, which will be found in the area over here of the screen. Other questions from this topic of, I guess it's histograms and averages from frequency tables, can be found in the playlist that will appear at the bottom over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.